All right, kids, as you can see, this says review. I'm going to go kind of quickly because we've done this before, but also because we're going to, have our Zoom lesson as we always do at 1:30. That way we can have some back and forth discussion. So I really, would like to have you there. Here we go. This first one is in vertex form. I hope you recognize that right away. So the vertex is 1, -16. This thing opens up because it's positive a value, invisible 1. Because it opens up, that means it has a minimum. And the axis of symmetry, of course, matches this x equals 1. So these first things we can answer right away. Now the y-intercept, remember, don't blow it and put down 0, -16. That's only if it's in standard form. This is in vertex form, so we actually have to change, we actually have to change the x value with the 0, and -1 squared, of course, is 1, so we get y equals -15. So that's 0, -15 is the y-intercept. The x-intercepts, actually I can show that right now, -15 is right there. My vertex, is 1, -16 right there. This isn't a critical point, but I know there has to be a symmetrical one to this. So I'm going to show that. And now I'm going to find the x-intercepts. Remember, that's the same thing as finding the zeros. So I replace f of x with 0. Remember, this is that newer technique that we did. We want to get the parentheses by itself. So we move the 16 over. And now we take the square root of both sides to undo this. And you get 4 equals x minus 1. But remember, you have to also look at -4. Okay, so when I solve this, I move the 1 over, I get 5. When I move the 1 over here, I get -3. So I get 5, I get -3. And my parabola is taking shape. Again, I'll sketch in the axis of symmetry. Makes me feel better. It's not required, though, unless it specifically says. Sketch the graph showing at least 5 points, which we did. Remember, we had 4 critical points, and we got that 5th one by doing the mirror image of the y-intercept. Now, this next one, I hope you recognize what form it's in right away. That is in standard form. So there's different things that we know right up front. We know that this is -3. That is the y-intercept. And we know that this positive a value means this opens up. Now, the x-intercepts, those are the zeros. These numbers are pretty small. I'm going to try to factor this. 3 and 1 plus, I think that's comes out nicely. X equals -3, x equals 1. The vertex, remember, is opposite b over 2a. So that would be -2 over 2 times 1. That comes out to just be -2 over 2, which is just -1. Now remember, that is the x value only. We have to plug in to get the y value. Now I'll do that up here. -1's quantity squared is +1. -1 times 2 is -2. So we have 1 minus 2 minus 3. That comes out to -4. So here we go, -1. 1, 2, 3, 4, -4. My zeros were -3 and +1. Okay, my y-intercept, -3. Now I'm going to go ahead and put down the axis of symmetry. Now I know it asks for it further down here. It says, so that would be x equals -1. And I'm going to draw that in here. Now remember, it says the sketch using 5 points. Well, right now we have 4 critical points, but we know the mirror image of this y-intercept would be right there. So that's our 5th point. And there we go. Okay. Whoops. Skipped a little too far. This next one is kind of a hybrid. If you take a look at this, well, no, it's not. It is in standard form. It's just that it doesn't have the C term. No big deal. An invisible C means that the C is actually 0, so the y-intercept is the origin, 0, 0. This one opens down, so there's my vertex right away. The x-intercepts, that means find the zeros. You know what? I think I can do some factoring here. I'm going to multiply both sides by -1. So that becomes 2x squared minus 4x. I'm going to factor out a GCF, which is actually 2x. And I get x equals 0, x equals 2. Those are my solutions, which actually matches up with the y-intercept that I already have there. Okay. Now my vertex, you can actually tell what the x value is going to be just by looking at these two solutions. Anyway, the x value, opposite b over 2a, well, the opposite of b is -4 over 2 times a. -4 over -4 is simply going to be 1. So I have 1 comma something. So let's see. 1 squared is just 1 times -2 is -2. -2 plus 4 is 2. So my y value is 2. So I do only have 3 critical points here. Happens sometimes. Notice how it doesn't say to graph using 5 points. There you go. There's the axis of symmetry. We can write that down here. That's x equals 1. Now this last one, it's actually, you can think of this as you know, we're gonna think of this 2 different ways. We're gonna think of it as standard form first. Standard form, this is A, invisible 1, so it opens up. This is the y-intercept hanging off the back, so 0, -9. All right. Now, I'm also going to think of it as vertex form. Remember, I could rewrite this whenever you don't have that b term. The equation can be written either way. So by thinking of it vertex form like that, I don't have to do any opposite b over 2a at all. I'm right there. Okay. Now the x-intercepts, we could solve this. I'm going to take this standard form and use that. Replace f of x with 0. I have no b term, so I move the 9 over, take the square root. Don't forget to say plus or minus. And we're done. Now remember, the y-intercept and the vertex were the same for this particular problem, so we are actually done with this. We can just do 3. There's just 3 critical points. The axis of symmetry is right down here on the y-axis itself. Remember, the value of x in the vertex was 0, so this is x equals 0. And that is it for that. That was pretty short. That was a review. I'm hoping you're comfortable with that. Remember, for details, we are going to do a live Zoom lesson. See you then.